Good day, Doctor. We are from S2G1 Group D. We are going to present about our AIPM project with the title Smart Camera Recommender System by LNG.
Hello, Prof. This is our project overview. What does our tool do? Our tool will recommend the best camera based on the user's budget and intended primary usage. For us, we choose three, which is photography, hybrid, and videos. It also uses a real-world camera dataset, applies a scoring algorithm to rank suitable cameras, display result through an interactive UI, and the target users are photography enthusiasts, videographers, and consumer looking for data-driven camera decisions.
Moving on to our project planning, to ensure we met the strict academic deadline and the client's requirement, we utilized Microsoft Project to construct our work breakdown structure and schedule. As Doctor can see, we constructed the project into 4 distinct phases over total duration of 65 days, running from October 17, 2025 to January 15, 2026. For phase 1, we focus on research and requirement gathering to understand Linux Media Group's specific needs. For phase 2, we was the core evaluation and testing phase, where we developed the algorithm. For phase 3 and phase 4, we covered documentation and final delivery. We monitored the schedule performance index SPI weekly against the baseline to ensure that even with the iterative nature of coding the AI, the overall project remained on the critical path. Next, looking at our cost and resource management, we operated with a total estimated budget of 80K. We utilized AI-based regression estimation techniques to validate this budget before starting. The allocation is broken down as follows. So we have 15K was allocated for data collection and cleaning, which was labor intensive. 15K went towards analysis tools, including software licenses. The large portion, 50K, was dedicated to reporting and presentation materials to ensure the final deliverable met the high production standards of Linux Media Group. In terms of resources, we heavily rely on the Linux Tech Tips review dataset for benchmarking and public camera specification data to train our scoring model.
Next is our key features. Our first key features is the GUI. The GUI will have a budget input for the user selection for the categories, and one-click recommendation. The user interface is also clean and friendly to beginners. There's also intelligent recommendation logic, which filters camera by and price over budget and matching usage categories. The scoring of the camera is 60% for the resolution and 40% for the price. You also have a automated data handling. Handling will read the Excel file or this, in our case, CSV file. It also handle the missing values and ecosystem column names. It also will infer cameras category from model names.
Next is our flowchart. This flowchart explains the camera recommendation system based on the user budgets and purpose. The process starts when the user enters the budget and the purpose of the camera. Then the system will check whether the budget is valid. If the budget is not valid, the user need to re-enter the budget. And if it is valid, the process will continue. Next, the system will filter the camera within their given budget and match their features. After that, the system will rank the available camera options. The system then check if there is any suitable camera. If no suitable camera is found, then the system will display no match. If a suitable camera is found, the system will show the recommended camera. Finally, the process will end after displaying the result. So next is our technical architecture. The first one is data layer. The system uses an input dataset called modern camera dataset.xls. During the pre-processing, the data is standardized, prices are converted into numerical values, and the camera resolution is normalized and camera categories are inferred. Next is the logic layer. In this layer, the system filters the data based on their inputs. The values are normalized, including resolution normalization and price inversion. A final score is then calculated using the formula, which is final score will be 0.6 multiplied resolution plus by 0.4 multiplied by price. Finally, the GUI layer is implemented using the MATLAB figure. It uses a grid layout system with interactive callbacks and provide real-time status updates to the user.
So, how to use the system? First, ensure the dataset file is in the MATLAB current folder, then open MATLAB. Save the source code as camera GUI app.m and simply run the command in the terminal to launch the GUI. Once the app is open, the user enters two simple inputs, their maximum budget and their primary usage. After clicking the Find Camera, the system will immediately process the data and display the best matched camera along with a recommendation score. This score will help users to understand the quality of match relative to their budget.
For our future scope, we can add more possible enhancements, such as add more filtering options based on sensor size, brand preference, and weight limit. We can also add multi-camera recommendations, which will take the top 3, and we can add machine learning based ranking, add currency conversion, we can export recommendation as PDF, and lastly, we can use web-based version using MATLAB Web App Server.
To build this system, we utilize two primary tools. First, MATLAB. This serves as the engine of our project. We use it for all data processing tasks and to build the core AI logic, specifically the rule-based classification that drive our recommendation. We also developed the graphical user interface within MATLAB to ensure the user experience is intuitive. Second, Microsoft Excel. We use Excel to manage our database. It stores the modern camera dataset, which contains all the critical hardware specs like model names, prices, and sensor resolution that our MATLAB logic theories. For collaboration, we use GitHub to host our code base. Following a live development cycle, GitHub allows us to manage different versions of the software effectively, ensuring that every update was tracked and that the team stays synchronized. So here is our GitHub link.
Hello and good morning. Today I'm going to show you our project, which is a camera recommendation system by Linus Tactics. It's Linus Media Group. Today I'm going to show you the prototype. And make sure the file is in the program, the camera data. And then what you need to do is just run the code. After you run the code, this should pop up the GUI, and it doesn't matter what budget you want. Just put a budget, any budget, and then hit find camera, and it will show you what camera you should buy that is within your budget. So that's it from us. Thank you.
In conclusion, this project has successfully delivered a smart decision support system that solves the problem of choice paralysis for new camera buyers. We have effectively combined data pre-processing, a robust weighted scoring algorithm, and an interactive GUI into a single cohesive tool. Most importantly, we demonstrated how artificial intelligence concepts can be integrated into project management workflows, using data not just to recommend cameras but to estimate our own project risk and costs. The final outcome is a tool that is user-friendly, data-driven, and ready for real-world application by our client. Thank you, and we are now open to questions.
Why do you create this product?
We decided to do this product because we want to welcome newcomers to photography. Because we know when I first start, when we want to buy a camera, it's a daunting task. With this, we can see what you are prioritizing and what is within your budget. So from here, we can select it from the system itself. This is why we are creating